Hello, everybody. Welcome to today's webinar on hosting your Rails application at scale. Our presenter today is Mikel, who is the founder and CEO of Reinteractive. Mikel is well known in the Ruby on Rails community as a blogger. He is also the author of Mail, which is the Ruby email handling library, and he is known for his extensive work on the Rails Action Mailer component. Mikel is the author of the book Why Rails and will be launching his new book, Confident Software, this year. So welcome, Mikel.
Thank you very much, Rochelle. I hope you can all hear me okay. And yep, looks like it's good. Great. So we're going to be talking about Rails web hosting at scale. And the subtitle of this course, or this course webinar, is For the Rest of Us. So there's an awful lot of blog posts out there that talk about how you scale Rails when you are Google or Facebook, or not that they use Rails. Actually, they do in some parts, but yeah. Or, Twitter or Airbnb or any of the other large organizations that have used Rails in the past at some point. There's not a lot about how do you do it for just the normal application, the Rails application that's running the business, that's critical, that we need to make sure is running all the time. So that's what we're going to talk about today. So first off, feel free to ask questions. You can send them in the little questions box and I will see them and we'll either answer them then or there, or we'll answer them towards the end at the right spot. But don't worry about interrupting or anything. Just go ahead and ask a question and we'll work it out from there. So who am I? That's my mug shot. Yeah. I founded Reinteractive, as Rochelle said. I founded it in 2010, and we've grown over to 40 staff in 8 years, 30% average growth. And yeah, we've written a few things, built a few software companies, and written some software. The key thing is, though, that probably I've been involved in probably more than 130 different Rails applications now and seen different problems at different levels. So first off, Rails at massive scale, Shopify runs at a peak of 80,000 requests. GitHub and Airbnb and Fiverr and Groupon and Goodreads, all over 2 million other websites use Ruby on Rails. So there's a massive amount of applications out there at large scale. That 80,000 requests per second, that's a tweet from DHH, which is actually a tweet of a presentation done by Shopify about how they evolved and scaled their Rails application over 10 years or whatever it was. They started at Rails 0.5 and now they're at one of the latest versions of Rails. And they've been continually upgrading and expanding it since then. So it's well worth watching that video if you haven't yet. But there is a lot of Rails at very large scale. But Rails scaling for the rest of us, Reinteractive's OpsCare scaling, like what we do, we have clients that reach 1 billion requests a month, which is a lot. That's quite a large amount. But most Rails applications will never reach above this. And it still warrants thinking about it though, because the application, the way that it scales is important for its uptime and important for the way that it expands from there. You don't want a Rails application not built for scaling, because if you do need to scale, then is not the time to start modifying the code and fixing it. So I'm going to go over the following points in this presentation. I'll spend a bit of time on each one. Many of these could be a whole webinar in of itself. So I'm going to go through them, over the top of them, and point you in the right direction for each target item. And then if you have any questions about each item, please let me know and I'll just answer them in line. So first off, we should define what scale is. And when I mean scale, so we're talking about an application that's critical to the business, where performance is becoming an issue, or redundancy is becoming an issue, or customers are complaining. So this is where you've got a Rails application, you've been building it, adding features, and now you're running into a problem where there's too many people using it and it's not working by itself, just that one server on one host, or you've even got it on a couple of servers, but it's not being able to expand easily. You can't just click a button and add 4 more servers. or the database is starting to become a bottleneck, or whatever. All of these things are what I'm talking about when I'm saying Rails at scale. And I'm talking about business scale or corporate scale, not Google scale, right? There's only a few Googles in the world, and they've got a bunch of engineers can tell them how to do it. And funnily enough, actually building your application to be Google scale or Facebook scale or whatever up front, and following those blog posts of those engineers who are trying to handle, 100,000 or 500,000 requests per second, can actually be detrimental to your ability to actually launch the product, because you're spending so much time playing around with trying to get the ultimate speed out of it. You don't want to be doing this. You don't want to be trying to replicate a company that has 400 or 500 software developers or 1,000 software developers, and 5 or 10 of them are doing nothing but scaling problems. This is not going to get you any bang for buck. And I've seen this over and over and over again, where a developer will want to implement the latest thing that they learned from Google or Facebook's engineers into an app that only gets a few dozen requests a day. It's ridiculous. It won't help you. It just adds complexity. One of the problems with scaling is the more you optimize something, the less flexible it becomes. And the less you optimize it, the more flexible it is, or the more flexible you make it, the less it can be optimized, right? So if you've got and if you want a good example of this, you look at, say, a car, right? A very, very flexible car is not very fast and doesn't corner very well. You're looking like a van or something like that is actually probably one of the most flexible cars you could buy would be a large van with 4 or 5 seats in it. Now, the reason that's flexible is you can do pretty much anything in it. If you get a big enough van, you can move a mattress inside it. You can park it pretty much anywhere. You can take 8 people if you needed to. There's a lot of flexibility in that van, but it's not optimized for any one function. So then you start optimizing to be a family car. So now it's a bit smaller. It only holds 4 or 5. It doesn't have a massive boot, but it's a bit more optimized and it does what it needs. But then you want to optimize for speed. You go to the nth degree of that, and you've got a Formula One car, which is useless for anything except going fast. And the same thing happens with applications. As you start optimizing down a speed path, you're making it less and less flexible to do different things in the future, and you're locking yourself into a situation. So this is an important factor. You don't want to be trying to use Google scale type, megacorp scale type systems on a small application. Classic example of this is microservices architecture. You might have heard about it, where it makes a lot of sense to split up your whole application into dozens of microservices. That only makes sense if you have 3 or 4 developers available per microservice in many cases. Of course, there are exceptions to this rule. There's exceptions to every rule, but in the vast majority of cases, you're going to be better served by just one big application that you optimize a bit. So the first part of scaling that we consider very important at Reinteractive, and we build into our OpsCare service, is this whole idea of 12-factor, which was released by Heroku, and they created a website called 12factor.net. And this goes over a whole bunch of points about how you make a scalable application. I'm not going to go through in detail all of these, but to give you some examples, right? Like the code base needs to be accessible in a source control repository available to all the developers. That makes a lot of sense. Dependencies should be known and vended in so that it's part of the package and part of the application so that you can get that running. And it should work both in development and in production. The config should be held in variables inside the system, not hard-coded into the software, for example. This 12-factor net site, I'll actually open it up for you. So this is the 12-factor website. Okay, good. So these are the 12 factors that we talk about when we're trying to get the application running on OpsCare, for example, which is our software service. So the backing services need to be as attached resources, which means that they can be swapped in and out. They're not hard-coded into the application. that you build, release, and run, which allows you to have developers working on something which then gets released and then built and sent out into the application, into the production environment, and so on. We focus in on this. It's well worth, if you are developing software and you've never read the 12-factor site, to go and have a read. One of the really important ones there is development production parity, number 10, which is making sure that the development environment and the production environment are as similar as possible, so that if you can produce a bug in development, it will also appear in production and vice versa. That makes debugging an application very easy, or much easier. Being able to have number 8 and 9, concurrency and disposability, are also important scaling points. In the OpsCare stack and in many scaling environments, you'll find that each instance of the application shouldn't share anything with anything else and can scale out horizontally, which means you can add more of those servers without any configuration changes. There's 2 broad types of scaling, which I'll go into in a minute, which is scaling vertically and scaling horizontally, and I'll explain that soon. Concurrency is therefore a major part of scaling, because you need to be able to have more concurrent processes if you need them. Disposability is the flip side of that. It shouldn't matter that you shut down a server, and the system should recover from that and be able to scale down, because you don't want to just scale up and then have a massive bill for the rest of your life. You want to be able to scale that back down again. So that's the 12-factor site. Highly recommend you read it. And what it gives you is basically a viewpoint when you're coding the application to make sure that it can scale in the future easily. When we onboard an application to OpsCare, one of the first things we do is we sort of 12-factorize it. So we go through and we check off the various 12 points and just make sure that the application fits within the scaling environment we're going to give it. So when you're building an app for scale, like what I was just talking about, you want to be able to set up for multiple instances. So quite often, this whole shared nothing approach, which is the last point there, but you should be able to have it so that the application itself can boot up, and if it needs to write to disk, it's writing to some disk externally. It's not writing to its local hard drive that some other application is expecting to have access to. It's building up in such a state that it doesn't care if there's 1 of it running or 10 of it running. And sometimes this can be a problem. You know, you have background workers that expect that it's the only one working on the thing that it needs to do in the background. You also have this idea of multiple roles, which in OpsCare is talking about where we have our web role, which is the web instance, which serves all the front-end traffic to the clients. We might also have a background worker role, which is like sending the emails or doing some data processing or doing imaging. We might have other background worker roles, which are like urgent worker roles for very short term jobs that you don't want blocked behind large data import queries and things like that. Also, quite often on a scaling application, you want multiple databases. So you might have your Postgres or MySQL database, which is your main data store. You might also have Memcache or Redis, some other database that's sitting there that is providing you with either a NoSQL or just a key store value application that allows you to cache things and use them for background workers and things like that. So the application needs to be built with this idea from the start. These sorts of points are not hard to do in an application. And if you know about them, you can easily avoid them with the developers. So the next one is hosting providers. Where are you going to host the thing? You can obviously do it on your own servers inside your own office if you have a system administrator. The problem with that is that you might not be able to scale when you need to. Your internet connection might be a limit. The physical server itself, you need to buy a second server or a third server and go from there. So there's a lot of reasons for a small application to use an organization like AWS, Heroku, Azure, Google Cloud. Which one you use really depends on what you're hosting. If you're doing it directly or through a partner, and obviously if you do it direct, you need a lot of internal knowledge requirements around that hosting platform. How to choose? This is really comes down to the feature sets, and probably the most important thing on how to choose is what internal knowledge you already have. If you already have a team that understand Heroku, then use Heroku. If you already have a team that understand AWS, use AWS. Really, in terms of the ability to scale your application, most of them, like there's a very similar core set of features which allows you to do that. If you are going through a partner like reinteractive with OpsCare, we will put you on the appropriate one between AWS and Heroku, depending on your stack and what you're doing, because they are slightly different and they do have slight benefits. But if you are trying to choose, you can talk to us. We'll give you our viewpoint. Obviously, it will be a little bit biased. But for example, if you come to us with a Microsoft app, we're not going to tell you to put that on AWS. We'll probably tell you to put you on Azure, which is Microsoft's cloud. It does matter which hosting provider you choose, but it matters less than having a competent partner or team in doing the scaling. So I wouldn't concern too much on this. One of the big ones that can sway your decision though is what availability zones they have. If you need requirements of a server running in a certain country, you might find that your hand is forced to use a certain partner. So that is something to think about. So one of the things we do at OpsCare is we do this thing called pre-baked deployment. And pre-baked deployment is a process where you take the application, you build a new version of the application while you leave the existing one running. You do all of your deployments on this new instance of the application, which is sitting to the side and not servicing requests. And it builds up the whole deployment, installs any of the software dependencies, does anything it needs to do on the database. And then once that's done, it then inserts itself into the production environment as a pre-baked deploy. So it sort of saves itself to disk, if you like. And then the production environment just adds a couple more of those servers and kills off the old ones. The reason you do it this way, and the reason this is really useful, is that a deployment can take minutes, some cases half an hour. I've seen very long deployments where all sorts of stuff has to happen. And the actual process of deploying quite often doesn't need to be repeated every time the app starts, right? So you only have to install the dependent software once, and you only have to pull down the new code from the source control repository once, and all of this sort of thing. So that only has to happen once. You don't have to compile the code. You only have to compile the code once. So once that's done, you just have to start the image of the server. So that's what we do. We pre-bake it, we create an image, and then we start that image on the servers with 2 new servers, or double the number of servers that are there with the new image. And then once they are running, we then shut down the old ones, and now you've got the new servers in place. The advantage of that is if you're in production, rolling back just means you boot the previous image, which is very fast. So you can roll back in 30 seconds or a minute, as opposed to 10 minutes or half an hour having to do a new deployment of the old version. So it's a very speedy way to go forward and backwards. It also means scaling is very fast, because adding a server means you just have to spin up a new server. You don't have to code anything or deploy anything or install any software. We had one client that scaling was such a problem for them that they would have 2 servers running with all of their code, and they had a 3rd server sitting there. And when they needed to scale, they logged into the 3rd server, did the deployment to bring it all up to speed, made sure it worked, and then added it to the pool. So scaling took them between half an hour and an hour, depending on when the person was available to do it and all that sort of thing. That was quite untenable for them. I mean, it worked, but it wasn't an optimal solution. Blue-green deploy is this idea, and we have that baked into our OpsCare service, that you have a green environment and a blue environment. Both of them are good environments. Both of them are production environments. But basically, when you add the extra servers, those new servers are blue, and then we know they're working. And once we know they're working, we can shut down the green environment and then have everything on the blue environment. So it just means that you don't replace your existing good environment in production with a bad deploy. You wait for the new deploy to be good before you switch it in. a very important part of scaling is building deployment routines, because you need to have a very simple way to deploy code. When your system is being hammered by users and the software is taking too long to load, and you quickly code a fix to make it faster, you don't want the deployment process to be a complex multi-step manual process where you might miss something. You want to be able to just go deploy, and the new version gets into production as fast as possible. It's a very important part of scaling. You just want to be able to do that. You don't want to have your software developer trying to fix a problem at 11 p.m. on a Friday, and all he really wants to do is go home, and he finally finishes it and he forgets step 3 of the deployment process. You want to automate these processes as much as possible so that they are literally either a one-click or a one-line command. Finally, you need a rollback ability. This is important in scaling as well. You've done this deployment, you see that it's wrong, you need to be able to do, again, a one-line thing which rolls it back. You don't want to be sitting there trying to log into the servers and deinstalling software or uninstalling software and trying to figure out what you have to do to get it back to the way it was. You want a one-click button, and all good deployment systems will have that. And if yours doesn't, talk to us, we'll help you. So I spoke before about scaling, and you can scale horizontally or vertically. So horizontal scaling is where you have, say, you have 2 computers and they're both medium servers, right? If you're scaling horizontally, you would add 3, 4, 5, 6, 7 medium servers to add additional load. Now, the way that works is, say you have 1 medium server, it might be able to run 4 instances of your software on it to service 4 people at once. Well, if you have 2 servers, now you can service 8. If you have 10 servers, now you can service 40, in theory. There's other things that come into that, but that's basically horizontal scaling. Vertical scaling is where you have 1 medium server that services 4, and when you want to scale, you make that server bigger. So now you make that server from a medium instance to a large instance. So now instead of having 4 of your processes on it, maybe it has 8. Both are completely, valid processes. Horizontal tends to be a little simpler because you don't have to take the instance down. Like the existing services don't have to shut down to add more capacity. Obviously, if you're going from a medium server to a large server, you're going to have to reboot that system in the cloud to add more servers. Or if you're doing it in the office and you're running on your own hardware, you're going to have to turn it off and add more CPUs or add more RAM or something. So you're going to have to turn it off or turn off the existing infrastructure in order to scale if you're doing vertical scaling. Horizontal scaling, you just leave the current servers running and you just add more. The new ones you add might be a bigger instance type, like you might have 2 mediums running and you add 2 larges. That's also fine. And then the expectation would be you'd shut down the mediums and now you just work on the larges. So that's a way to sort of vertically and horizontal scale at the same time. In our OpsCare service, we can do both. The most common, though, is horizontal scaling. Scheduled scaling according to time. So we have users over in the US and Australia where most of their traffic happens between 9 and 5 p.m. business days, and then after hours, no one uses the application. So what we do is we actually scale up and we add, with some horizontal scaling, double the number of servers between, say, 8:30 and 10 a.m. And then again towards the afternoon when everyone's rushing in to finish, and we scale it back down in the middle of the day, and then overnight we make it to the absolute minimum so that they're not paying for servers they don't need. And this is just automatic, happens every day. The client doesn't think about it and just cuts down their bill massively. It also means we can scale down their staging environment, which is a key part of any scaling application actually. The staging environment is critical because you need to be able to test new features before you put them live. So, however, you don't need the staging environment running all the time if the developers aren't working on it. So again, you can scale staging down to 0 servers overnight, saving you more money. We also can do auto scaling according to load. So this is where the server's requests, the number of requests to the server is getting more and more and more. So you have some monitoring tool that's monitoring that, and at a certain threshold, you start automatically adding servers. Now this works. It's really hard to get right. You would think it's really easy, but you have to sort of define what load is. And sometimes that can be quite a challenge because there are many factors to consider when you're talking about load. There's CPU time of the server, there's how much memory it's got left, there's the queue depth, so how many people are waiting for a request, and then there's the queue time or request time. How long does each request take before it's being serviced? So there's a lot of critical factors around this. We successfully do auto scaling. It's not that it can't be done, but you need to really understand the application and its parameters and performance to get auto scaling right. And working with someone who really knows about it, or a partner or something like that, is a good idea. Finally, separate roles make scaling fine-grained. So remember when I was talking before about separate roles, having a web role and a worker role and maybe an urgent worker role? Having these as separate scalable items makes a lot of sense, because maybe you get a lot of data processing stuff come in. Well, then you just scale up the data processing workers. Or maybe there's a lot of web traffic, you just scale the web servers. You don't have to scale all the background workers and things like this. So having those as separate roles from the very beginning makes your ability to scale much simpler. Large data set management. So this is actually a problem. Large applications usually have large data sets. If you have a large data set, even just doing a deployment with a migration in it can require a huge amount of downtime. We've had situations where the service had to shut down for many hours to do a database migration. There are ways around this. The common reason to shut down a database during a migration is because of creating indexes can cause locks and things like this, or large data set changes that would leave the database in an inconsistent state if they failed, and you don't want people inserting into the database while this is happening. There are ways around this, pretty much in every case. You can engineer yourself out of downtime on the database pretty much all the time. It's the only real, anyway, there are situations where you do need to shut down the database, mainly for large version upgrades and things like that. But even that, if you really can't have downtime, you can work around that. It's not easy, but it can be done. So this is something to think about and need to make sure that your application can handle it. One of the common problems is the database dump each night can just take too long if you haven't got that set up properly, where it just takes far too much time to even do the backup. Another really key thing to think about is once you start getting into a big application, if something goes wrong and you need to do recovery, and it can take a long time to rebuild a database and restore it from disk, and you lose all the data that you've had in that meantime. So we have a capability in OpsCare to spin up a second database off a backup, and then allow you to pull some data out of it to restore, say, an individual's data. It's not easy to do, it takes a long time, but that can avoid you having to shut down the whole system. But having that knowledge means that, when you delete a record in the database, maybe you do a soft delete, which just marks the record as deleted, and then a week or two later, purge it from the database, so that if the customer goes, whoops, I didn't mean to, you can fix it without having to do a full database restore. This is all thoughts around scaling and things like that. And when you start getting big and you have people live all around the world, as many of our applications do, you don't really have a maintenance window, where everyone's asleep at 3 a.m. because somewhere it's not 3 a.m. So you need to have a look at, when you're getting to this scale, which is sort of another level of scale from what we were talking about before, this is where you start having to look at, well, what do we do when we've got graceful failures or maintenance pages, and making sure we can roll back, and notifications to users and all this sort of stuff. It's just something to think about at that point. Another key part in scaling is monitoring your application, making sure that what is happening is what's meant to be happening. This can get really complex. Some of my developers or ops team love this stuff, and they really get into it and find all sorts of things that are happening in their applications and figuring it out. But there's a lot of stuff that's just fluff. and noise. And you really need to look at the metrics to see what is fluff and noise. We at Reinteractive use a bunch of monitoring and support tools like Pingdom, Skylight, CloudWatch, VictorOps. They're all applications that allow us to see into the app itself and make sure that it's running. Another one on that also is Bugsnag, which is monitoring all the errors that are happening on the application. So all of that's included in what we do, and it's, you know, it's good to make sure that you have one of these or more of one of these things in place. Quite often just having Pingdom, for example, on an application won't actually give you the monitoring you need because the site might just be a bit slow or it might get a false positive. So you need a couple of these monitoring solutions looking at your application, especially if it's really critical. Of course, you can set all that up yourself or you can talk to us. Backups is probably the last major point that is the large major point I'll go over. There's different types of backups, and these all matter at scale as well. So we take snapshots at databases. We make sure that you've got a complete backup as well that you can pull down if you want. But one of the key things that you need to do when you're at scale is test your backups and test the restore. So we do that monthly and make sure that that backup and restore is available for you for when the application does get to the point where it needs something fixed. The last thing you want is to do a backup and then do a restore and find the restore doesn't work. So that's a pretty critical thing. All backups should be automated as well. You should never be relying on a manual backup process. So get that automated, but then make sure the automated backup is tested manually, often, at least monthly. So that's the broad look at the scaling side. I like keeping these webinars fairly short and sharp. I'm more than happy to answer any questions as you have them, and we'll be approaching the end soon. So if you do have a question, fire it in now and I'll give you some more data or I'll dive a bit deeper on something. So finally, OpsCare, what is that? That's our managed hosting for Ruby on Rails applications. We include the 24/7 monitoring, we include the break fix, and a bunch of the stuff that you've just seen is all built in for free. It's just part of the package. So if you do have a Rails application and it's starting to grow and scaling is going to be a problem, talk to us. We can definitely fix it for you and make sure that that application can scale as much as it needs to scale into the future so you're not sitting there with upset customers and complaints. So that's the webinar. If you've got any questions, please give us a bell, send us an email, visit the website, or ask it now. Otherwise, thank you so much for all of your attendance and for being attentive. I really appreciate it. I didn't want to take up the full hour of your day. If you have any specific questions on any part of what I've just gone over, like actual application, feel free to send us an email and we'll give you a reply and point you in the right direction of what you need to do to get that done. Because trying to talk about specific, you know, install this service or do this bit of coding isn't really necessarily apply to everyone. So we haven't put that on here at the moment. All right, good. Well, I think that's going to be it. This will be up on the website a bit later as a video. And if you do have any questions, we will reply to them via email. And otherwise, thank you very much for attending. And I hope you all have a fantastic rest of your day. See you later.